This is page 9 from chapter 6. Example 3, a pendulum swings at a total distance of 0.30 meters. Center point 0, it completes a cycle every 2 seconds. Assume the pendulum's at the center point, heading right at t equals 0. Find an equation for the motion. So if we try to graph this, if we start at 0 and it's heading to the right, between a sine and cosine graph, if it starts at 0 and it's heading right, we can think that it's a sine graph, that it looks something like this. So basically, it completes a cycle every 2 seconds. That's the period. And then it swings a total distance of 0.30 meters. That means from highest point to lowest point is 0.3, that distance. So therefore, we could say the amplitude is half of 0.3, so it's 0.15, because the total distance is 0.3. So that means if the highest value is 0.15, we can think the lowest value is negative 0.15, and that's a 0.3 distance. So if the period's 2, it's in this form. We can just say it's like this, and I'm using t instead of x because t is the variable. And basically from here, instead of 2t, it's not a 2. I'll just call this like bt. And to solve for b, I could say 2b divided by b gives me the period of 2. And if I solve for b, b would be pi. 2 pi divided by pi is 2. So the final equation would be 0.15 sine of pi t. That's a b. Determine the distance from the center at 1 second, 1.5 seconds, 1.75, and 2 seconds. So you're just plugging those in for t. I'm plugging in 1, I'm plugging in 1.5, and this again is radians. And you can use a calculator. And if we plug in, first one gives me 0, second one gives you 0.15, third one in radians gives you negative 0.11, and the last one's 0. Example 4, the Sears building in Chicago sways back and forth at a vibration frequency of 0.1. Remember, frequency is the reciprocal of the period. So the period would be 1 divided by 0.1, which is 10. So if the frequency is 0.1, period is the reciprocal. So on average, it sways 6 inches from the true center. Write an equation of the sine function that represents the behavior. It sways 6 inches from the true center on average. So we would say the amplitude is 6. It goes like 6 inches up or whatever from the true center. So y equals 6 sine of, let's say, bt. And to solve for b, it's just 2 pi divided by b is the period, which is 10. And then we could solve for b. Put this over 1 and you can cross multiply. And then you get b is pi over 5. And then you would just plug that in for b. Y equals 6 sine of pi over 5 times t. That would be example 4. Section 5, translations of sine and cosine functions. A horizontal translation or shift to a trigonometric function is called a phase shift. This would be the general form of a sine or cosine function. I'm going to write it a little different, and I'm going to write it like this. Y equals a cosine of b times theta minus h plus k. Or for sine function, y equals a sine of b times theta minus h plus k. I'm going to write it in this form. So in general, we would say the amplitude's the value of a. The phase shift, it says theta minus h. The phase shift is just h. Whatever value that is, that's how far it shifts horizontally. The period is going to be 2 pi divided by b. And then the vertical shift is the value at the end, which is k. So example 1, graph each equation. So because nothing's in front of the cosine, we see the amplitude's 1. Period is just 2 pi, because that's really 2 pi over the number after the cosine, which is a 1, and 2 pi over 1 is 2 pi. Phase shift, it's really the opposite of what's in the parentheses. It says theta plus pi, so the opposite of plus pi is negative pi. Nothing added in at the end. There's no vertical shift. So in order to graph this, we can do it like this. If the main period is 2 pi, these are your 5 main points. 0, halfway in between is pi. Halfway in between 0 and pi is pi over 2. And then 3 pi over 2. However, the graph is shifted pi to the left. We're going to take all of these and shift it pi to the left. So if I subtract pi from each of these, we would get negative pi over 2, 0, pi over 2, and pi. So what I'm going to do is this. I'm going to plot these 5 points on the x-axis. And I'll have a scale of -1 to 1. And cosine graphs start up at the amplitude, then to the x-axis, and then the minimum, x-axis, and then the maximum. So here's the graph under a shift. So it shifted pi to the left. If there was no shift, the graph would have looked like this. It would have started here. It would have done this. I'll just graph this very lightly in red. So the graph that we're interested in is the one in black right here. That encompasses the shift. You do not have to graph them both. I'm just simply showing you red would have just been y equals cosine of theta. The one in black deals with the shift y equals cosine of theta plus pi. All right, that's example 1 on the bottom of page 9. So these are the notes from chapter 6, page 9.